Bud, what did we get via the UPS? It's a large box. A large box for a large cat. Well, all right. I'm done with you now, Bud. I don't need you anymore. Leave the shot. This is a new printer from Anycubic. They sent it to me so I could do a review of it. So I think this is the third Anycubic printer I've looked at. Okay, so this printer apparently is self-leveling. I think it uses a pressure sensor on the nozzle. And when they told me that, I asked them, well, what do you do if there's some filament on the end of the nozzle? Because that would affect the positioning of it. You know, if there's a little bit of dried filament on the end. What is this? It's kind of like a robot arm or something. Oh, it's a detachable screen. That's kind of cool. Anycubic Vyper. Oh, that's weird. The build platform is weird. It's got a kind of a texture to it. When I find myself in times of trouble, Mother Mary comes to me, speaking words of wisdom. We're gonna get you, Jeff Bridges. Now Bud is eating the egg carton that $34 printer came in. Now this looks like a bigger build platform versus the last Anycubic I looked at. Oh, it's a magnetic flexible plate as well. Can you hear that? You can't feel the texture, but you can hear it. Ah, that's cool. You know, I think, yeah, this is the first printer I've worked with that has a flexible plate, at least here. Bud, you're making too much extraneous noise. I'm going to banish you to the world of pagan now. Oh, looks like they have the same kind of extruder as before. Well, not the extruder necessarily, the gearing that actually drives the filament. So I guess this would plug in right here. Let's take a look at the Accoutrement Pack. That's a fancy French word that means accessories. Some PLA. Oh, an extra nozzle and memory stick converter. These are going to be the metric bolts that actually attach the frame to the base. Oh, gee, just what I needed. Another USB cable. Generic SD card. Oh, some zip ties. Power cable. And I'm guessing this arm is probably for the screen. So I'm guessing that these are threaded, the holes, and that's what the screws will attach to. Oh, what's this, a tray? What is... Oh, it's got tools in it. That's so cool. It's got a little flush cutter, a whole set of, oh, darn it, wrenches, and a nozzle cleaning thing. That's so cool, this little tray. I thought it was a power supply at first. Oh wait, the power supply is right next to it. Well, I can use these tools to put it together. Whoa, check out that funky pattern for the heat bed. Easier to do if I had a second pair of human hands, not kitten hands, because kitten hands aren't very useful. One thing that I don't like with this assembly, and I think I had the same problem with the previous printer as well, is that it doesn't really feel like there's a good, safe way to lay down a part like that. And I know you only really need to do this for the assembly, but still. You know, maybe something they could do is they could have a piece of the foam break away. Like the foam could break away in a certain shape to create the supports you need. I mean, I can just kind of put the foam in here. It's like, oh, put a perforation in the foam so the foam is the right height to do this, you know, to give it support. That would be kind of like a free thing they could do. It's like, how many times you buy like a power strip, right? And it's like in a little back, you know, package or a piece of cardboard. It's like, would it really kill them to print the pattern of the mounting screws on the cardboard so you can use it to mount it? Okay. There's a lot of connectors underneath this plate here that aren't connected to anything. Like that? Oh, like that. Well, that's kind of cool. I guess that's why they include these really small flush cutters, is because you have to remove these zip ties. Wiring. Connect all those wires to their corresponding ports by the label respectively. Okay. That could be communicated better. Are they labeled? Oh yeah, this one's labeled ZL for Z left. Or Z left if you're British. Oh, that's the Z left switch. Oh, it's optical. That's cool. I mean, I've, been using 3D printers for many years, and I've built 3D printers from scratch, so none of this stuff really confuses me, but like this makes sense. Like, oh, look, they've got a header here which breaks out this cable to the motors, and then this probably goes to the extruder head. See, I mean, I can figure this stuff out, but it might not be as obvious for a layman or woman. A layperson on a ley line, listening to Layla. Got me on my knees, Layla. Okay, the instructions did mention this. It's like, make sure that it goes under the beam, because obviously, as this goes down, that would not work. Okay, so they did label the switches, but the pictures are very small, and they've got red text on a black background, which is bad design, so this should be like a whole page with larger photos and text you can actually read. So that's something that they should improve. If you are moving axes on an inert printer, do it very slowly, because if you do it quickly, you'll actually create a current and possibly fry things. It's kind of crazy. Like, sometimes if you like really retch it, the printer will turn on. It'll actually create enough back current to turn on the electronics. After cutting the bottom tie, please shake the platform to confirm whether the printer platform is shaking up and down. Oh, I see. They've got those rubber wheels going along the channel. So what they're talking about is tightening up this hex piece here, the spacer to the nut. But it feels pretty good to me, so I don't think I'm going to mess with that. Oh, this must be for the belt. The, what would that be? The Y-axis belt? Neat looking printer. It kind of looks like a Decepticon. Also, the battery on this 4K Sony Handycam sucks. Back in the old day when we had the TRV 510 or whatever it is, the TRV 510. Look at this battery. Look at this giant battery. I bought this battery in the year 2000. This battery would let you shoot for like 8 to 10 hours. So it basically lasted all day. And the thing is, 21 years later, it still holds like 3 or 4 hours of charge. It's nuts. Oh, it's a good thing I checked. This thing is actually shipped at the 230 volt setting. Yeah, we need to set this to American volts. They're made out of bacon. So the robot arm turned out to be the filament holder. Yeah, so it looks like, oh, they have a filament runout sensor here again, it looks like. Yep, so the filament goes here, into there, into the extruder. I don't like this because look how much larger it makes the printer's footprint. They have the filament be here, go down like that. Maybe I'll build that. So apparently this one uses a pressure sensor for leveling. Oh, the instructions are in English and Mandarin. Auto leveling, the probing will begin. Okay. Use a tool to touch printer nozzle to calibrate leveling sensor. Okay. Touch printing nozzle. Oh, there we go. Oh, it probably was reading its 0 null value, and then when I touched it, it's like, oh, something changed. I assume that's how it worked. So I'm just now noticing this thing has a much higher Z build volume than the other printer I was looking at. Well, that also means this process takes longer. Although, most cases, you wouldn't be printing something that high, at least I wouldn't. So the nozzle's only going to be it's going to be parked about here, so it's not going to take this long to go down. We wait for the mating season of the whales. It will be a splendiferous thing to see. Oh wait, but that was the switch Z0. The optical switch? It's preheating the nozzle? Oh, it's probably so it takes into account the expansion of the metal and how that would affect the sensor, I'm guessing. Looks like some ooze is coming out of the nozzle. That was something else I thought about. Like, it would have to make sure that the nozzle's wiped, because if there was like, you know, solid strings of ooze coming out the end of it, that would affect the Z setting. Oh wait, it's moving again. Is it not going to do a wipe? It still says it's preheating. So you notice how it's doing two? So it's doing one pass, and then it's doing a slow pass, a secondary pass to verify the settings of the first pass. So I'm guessing, well, yeah, it's going to be setting up a mesh level. So I would think that internally the firmware would store the mesh settings, so you should only have to do this once. Look, bud, I let you back in, so you should be good. Oh, there he goes into the box. All right, filament. Okay. Filament in. I will say this touchscreen is way more responsive than the touchscreen on the last Anycubic that I looked at. The software is faster, and the touch, well, the other one I think was a resistive touchscreen. Is this one capacitive? Well, it's heating up, but in the meantime we can hack the planet. We should be able to pull this. Yeah, so we can pull this. Bud, what are you doing? I know what you want. You want to eat the straps on my MST3K hoodie. Well, you're not going to get those straps. So I'm just going to get the filament all the way up to the nozzle while it heats up. See, that way we don't have to use the motor. So that's kind of handy. We just release, you know, they've got a tensioner here, so you can release the grip on the filament and just stick it all the way through. One nice thing about Bud is he hasn't realized quite yet how high he can actually jump. It's kind of like, no, Neo, when you're ready, you won't have to. Like, he hasn't figured out that he could easily jump up onto the kitchen counter yet. This could burn you, and then you will become Dark Man Cat. And then you'll run around yelling, Julie! Okay, 220's gotta be hot enough. I'm gonna push the filament in button. Yeah, there we go. Here's the extrusion. Oh, it just keeps going. All right, filament, stop. This SD card had a Cura on it, and also some configuration files for the Vyper. Normally, I use Simplify 3D. However, I was reading up on this printer, and do you remember the previous FDM Anycubic printer that I took apart? I commented that it had an 8-bit microcontroller drive in it, and ironically, the microcontroller driving the screen was a Cortex M0. No, actually, no, it was a Cortex M3 driving the screen. And I was like, well, that's kind of funny. They have a much bigger processor on the screen than they do actually driving the printer. Well, this new printer has an M3 processor, so it's actually 32-bit, which means it would also have floating point with M3. So it should print a lot better. Anyway, the reason I went on that tirade is because I want to make sure I'm using the right settings for this printer so we can see it work at its maximum speed. All right, so we need to import those files. Vyper, okay, let's do PLA. Okay, now we have a custom profile for the PLA. I'm going to print one of these caps for my single-handed controllers. Let's see, layer height, infill. Why can't I change the layer height? A brim or a raft? Ah, we don't need that. Oh, this is probably because we created that or imported that custom profile. I'll do 0.2. I think that should work. Save to removable media, which I guess would be the SD card. SD card slot is right on the front. That's handy. Oh, it's upside down though. Analog cap G code. I guess that would be it. Print. Yeah, I like this. I like the orientation of this screen. I don't know, it's just handy. It's also much larger than the other touchscreens. So yes, compared to the touchscreen on the Mega Pro, this one is much nicer. When I do these videos, it's because a company sends me a product, but I don't actually take any money for it. I basically just take a free product. Bed heats up pretty fast. That only took about not even 2 minutes. You know, I was thinking about this, like, again, most of the time you're going to be printing at a low level, which means this arc is not going to be too severe. So if you put this up top, that means conversely, most of the time, you are going to have this big loop of plastic, and this might tend to happen, which wouldn't be good. It would create like a pinch point. Especially these plastics, they tend to get brittle and fracture over time. Oh, it started. Oh, okay, yeah, so this must have the TMC whatever drivers. What's that called? Oh yes, the TMC 2209. So it's a more advanced stepper driver. It's actually the same kind I put into that Flash Forge. All you can really hear is the fan. The motors themselves are silent. You hear the fan, and then you hear the rubber basically moving on the rails. It seems like, I mean, I would think it could be faster. The print speed, I mean. Although again, we got a Cortex M3, which means you've got floating point. So the maths, as the British say, are going to be a lot better. Yeah, this texture, I haven't felt this in a printer before. I've never felt this way before. It makes sense because, like, by having a slightly rough surface, the first layers of plastic would fuse around it, acting, well, not kind of like it would be like a mechanical retention. Then you'd think, but yeah, okay, I guess the inverse of that, or the problem with that, is that it would stick too well, which I guess is why it's a flexible plate. Yeah, here's the surface of the Anycubic Mega Pro. See, it's got like kind of like this. Well, this is borosilicate glass, and looks like they've etched a texture into the glass. This actually works really well. I don't have to do any additional adhesive or glue. It just sticks. It just works. I mean, I obviously had to make sure it's clean of dust. Check it out. You can see the toothed gear moving. That portion there, the fine teeth, that's what's actually gripping the filament. And the gear spurs down here, that's actually interacting with another gear on the other side. So there's actually two gears that mesh when this pinches together. So that's actually a cool part of the design, the fact that the compression wheel on the other side is synchronized with the drive gear. I did have trouble with this extruder type when I was working with the Mega Pro, in that when you feed the filament through, sometimes it's hard to actually get it through this nozzle. So if the filament has any sort of deviation to it, it'll bump up against the edge and not go through. And I actually fixed it by going in and chamfering it out with a V-bit. I think another potential issue you could have with that, if you've got a really narrow aperture, especially an aperture that's enclosed that you can't get at, is when you retract the filament, when you pull the filament out of the head and it comes back, you're going to have like a little bit of a blob on the end, like a randomized blob, which is probably going to be wider than the diameter of the filament. And that also might have trouble passing through. Of course, you could just pull this out and cut it, pull off this tube. Okay, so this is running at 4,800 millimeters a minute. I think I could go a lot faster than that. Kira said, what, 22 minutes? This is 38% at 17 minutes, so I don't think that estimate is gonna, they're not gonna make that ship date. This totally looks like the Decepticon logo, right? Coronation Starscream? This is bad comedy.
Megatron, is that you?
Here's a hint. It's done. Took 30 minutes, so it's 8 minutes slow. Yeah, that really adhered well. I guess you pretty much have to do this. This is gonna be like an ice cube tray kind of thing. She even took the ice cube trays out of the freezer. Kind of tricky because as soon as the magnet catches, see, it just goes straight down. Oh, the print quality is very good. Look at that. That's a really good print. So look how shiny it is. Shiny. What I'm going to try next is I'm going to try setting this up as a printer in Simplify 3D, and then I will print it again. I just thought I'd take a look at the Kira profile. I thought it would be XML, but it's not. Even got some binary stuff going on here. Vyper. So the Vyper is technically an Anycubic i3 Mega. There's not actually a lot of custom data here. I don't see why I couldn't just set this up in Simplify 3D. I could just modify the i3 Mega profile that I already have. Simplify 3D is cool. I just kind of wish they'd make a new version of it already. Yeah, let's see. Anycubic i3 Mega. Let's see if we can save as new. Enter a name. Oh, okay. Anycubic Vyper. All right, let's see. So we're going to change the build volume and some other things. Then we'll see if it works. Okay, here's my modified Anycubic Vyper. Print speed up to 180 millimeters a second. All right, that's too aggressive. I'm gonna go 9600, which would be 120 millimeters a second. Okay, scripts. This part I'm not sure about. These are the scripts. Well, those are the i3 mega scripts. All right, let's add a part and try it out. I'm going to print it to the SD card again. I like how liberal these printers are with the SD card removal and reinsertion. It's like you can just do it over and over, and it just works. It just auto mounts, which is nice. Yeah, all right. So this is the file that's generated by Simplify 3D. It's going to have a different startup and ending procedure. Oh man, I really need to schedule a haircut. The PDF instructions are included on the SD card. They are easier to read than the printed instructions that came with the unit. You still have stuff here like the cable instructions. I mean, if you zoom in, I guess it makes more sense. It's still not exactly a winning design. So, maybe like put a stroke around this text, a black stroke. Oh, I forgot to put that zip tie in. I guess it makes sense. You have two forms of strain relief then. See, I couldn't see this in the printed version, but looking at the PDF, I can see it. And the nice thing about the PDF is that it then continues on to more advanced setup measures and also how to get started using Cura. So I realized that the starting G code and the ending G code does change based off of your base printer via the Anycubic i3 Mega or like an Ultimaker or whatever. So I just copied these codes and put them into Simplify 3D here. Oh, look. The tray's even magnetized. Oh, the tray even has little magnets in it. Watch. Clunk. See that? That's great. Didn't notice before. There's a bright LED lighting up the part. That's kind of cool. I can see some blobbing on the walls. So I think the settings in Cura are better than the ones I created in Simplify 3D. Again, I didn't change anything. I just renamed it. So I think what I'll do is I'll go through all the settings, the machine-specific settings in the profile in Cura for this machine, and then I'll copy it over to Simplify 3D. But now that I have two baselines, I can basically dial it in and make the profile what I want it to be. I mean, yeah, this just seems like a very nice printer. I mean, $350 I want to say. I don't use 3D printers as a hobby. So I am perfectly fine spending the money on good ones. I mean, I showed that Maker Gear for crying out loud. Yeah, so I think if you're serious about 3D printers, unless you're on a super tight budget, I think it's, you can get them the sub $200 range, and Anycubic even has that. But for a few dollars more, you get a lot more printer. I mean, look at this build volume. I think this is the largest build volume of any printer I have. Oh no, what did I do? No, I don't want to stop printing. So that touchscreen is almost too responsive now. Oh, look, you can turn the light on and off. I believe it is a resistive touchscreen, but it's a much higher quality one than the Anycubic Mega Pro. Simplify 3D. I'm going to try hooking it up directly with the USB cable. That's interesting. Cura was open, and Cura captured the USB port as soon as I connected it. Also, when I turned off Cura, Simplify 3D was not able to communicate with the printer. So, yeah, I'm going to have to use Cura. So let's go to print via USB. So I've got like a little cylinder here. I'm going to try printing it quickly. Oh, okay. So this is giving me all the communication. Just going to heat up. Oh, I could jog it too. I have like 3 printers hooked up to this computer with USB. Then I have the Anycubic Mega Pro. That's over on this side of the room. So I've got an SD card running that. There's nothing changes on the screen that would indicate a USB connection. Guess it doesn't really need to. It probably means you can't change the speed on the screen while it's running either. I guess we could try. Well, yeah, but there's nothing on the screen. See, it's already getting commands. So again, this is Cura over USB. Kind of go through like phases of filament. Like I was in a big G-Tech phase. I used to buy the Amazon Basics, but did they even make that anymore? So then I got into the G-Tech phase, but now I'm into Hatchbox. So really what I look for is whatever filament is nicely wound on the spool. I also bumped this up to 120 millimeters a second. Sometimes these screens just act as a dummy G-code reader. They'll use a separate TX-RX serial port on the main microcontroller, and they'll just send and receive G-code, basically, like they'll say, oh, you know, they'll ping it, hey, what's the temperature, and then it'll respond to the temperature. This one seems to be more tightly integrated, although it is kind of weird that there's nothing on the screen as it's getting, well, aside from the fact that it's showing the temperature, there's really no indication like, you know, USB mode or connected to PC or something like that. Like, what happens if I... Yeah, I mean, I can go into these menus still. Voice? Does this work? It does. Yeah, you can see the layer change seam there. Aside from that, it's pretty good. I mean, it just... Yeah, it's a big stack of layers. I wonder if that blobbing that we saw was this being randomized across the part. Although this, I think, could still be smaller. Oh, we do get a print finished message on the screen in USB mode. Oh, the light just turned off. I'm going to print something kind of larger and more complex. I think I'm going to adjust the ending G-code to raise the print head a little bit higher when it's done. Because, you know, when you put the bed, you know, if you use a removable bed, you put it back in place, you know, it's easier to line it up here if the head's out of the way. All right, I'm going to print a larger piece that has supports. It's going to be at 0.3 millimeter layer height, so it's a coarser print quality, but I want it to print quickly. So we'll see how it turns out. So I'll be back in a few minutes. Well, like an hour. You know, that reminds me, like editing footage like this, where it's like, oh, you know, Ben was gone for an hour, but from the perspective of the person watching, no time passed at all. Like, what if we're in a simulated universe, but every quark length of time that, you know, the frame rate of the universe, what if every frame takes 100 years in some alien computer? Like, we wouldn't know the difference because we are programs in that simulation. Well, okay, yes, if we were programs in the simulation, not brains in a jar. Well, even then, maybe we would perceive it as being the normal passage of time. But yeah, imagine it's a simulated universe and that we are programs in the simulation, not brains in jars. So you could say, oh, it takes 100 years to render one, you know, quark frame. I'm sorry, not a quark frame, a plank frame of this simulation. Our minds, being programs, would only notice when something changed, kind of like pausing an emulator. So yeah, who knows? Maybe 25,000 eons occurred while I was giving this explanation of that. It's kind of, you know, it's kind of weird to think about because, you know, everyone thinks like, oh, you know, if you think about simulated universe, you think about the Matrix and oh, this has to work with biological organisms and it has to, you know, run at full speed. It's like, no, it necessarily wouldn't have to run at full speed. Like, think of it like a Pixar movie, right? Like, you get a Pixar movie, what is it, like 2 days for every frame, right? Kind of like that. But then when you play it back, it looks like it's full speed. So same thing is, yeah, your program of your mind, it only, you know, it gets the ping, it gets the edge that says, oh, a new frame is ready, and then you process it, and then you continue, and yeah, we wouldn't know the difference. Kind of crazy to think about. Okay, I'm just wasting time, you know, or eons of time according to my theory. Well, that's if the universe is simulated. I guess it might be. I mean, thing is, how would we know? You know, from our perspective, we couldn't really tell. Also, when it did the bed leveling, you know, is that, I assume that's in the firmware. It would be a mesh because it took all those points. Then I wonder, it's because it's using these. If I had to guess, it's probably using these limit switches, these optical limit switches, to know where the base Z is, and then it's adjusting the Z height as it runs based off of the mesh that it took, which I assume would be stored in memory. But then that begs the question, if they're using a Cortex M3, I don't believe those have EEPROM, so it must have a separate EEPROM for storing those settings. Or it could be using a non-volatile memory flash controller program to update a certain area of its own memory as flash. Because those ARMs don't actually have a dedicated EEPROM in them like other microcontrollers do. But they do have MVM. However, the MVM, you can't rewrite it as many times. Wow, I'm really getting off into the weeds here. Well, anyway, I'll be back in about 50 trillion plank times. See you then. Oh, I know why it makes me think of Transformers, because it looks like Optimus Prime's head. I don't know if that's something with the Z. Oh, I had one more thought with the simulated universe and Planck time, or Planck distance, which is kind of the same thing. Well, Planck time is... Planck... What, no, wait. No, yeah, Planck time is how long it takes light to move one Planck length. There's like this thought experiment about like things exceeding the speed of light, which could very well be the frame rate of the universe, which would explain a lot, actually. It would explain the limitations, or why it's a constant. It would definitely explain that. Oh, here's something to think about. Like, let's say you're like, oh, I want to transmit information faster than the speed of light. So let's say I want to transmit information from the Earth to Mars. And okay, this is a really stupid example, but like, let's say the planets weren't rotating around the sun, right? Let's say they were static in space, which I guess they could be. So the person's like, okay, I'm gonna make this rod that's like...
Mars is 227.6 million miles from Earth.
I didn't realize Mars was that far away. Well, anyway, okay, so let's say you made a rod that was 200 million miles long. And wait, you're like, okay, I'm gonna have this rod, and I'm gonna move the rod back and forth, and I'm gonna use that to physically transmit data. So it's like, oh, but you know, so I could... The rod is 200 million miles long, so if I move the rod 1 millimeter on Earth, it'll move 1 millimeter on Mars instantaneously, therefore transmitting data faster than the speed of light. However, that doesn't work, because when you move something, when an object moves, it's done in compression waves, and those waves, guess how fast they work? That's right, the speed of light. So if you did have this aforementioned rod that was 200 million miles long, assuming you had the force to push it 1 millimeter, which would probably be very difficult, but let's just say you had the ability to push it 1 millimeter, the rod would actually have a compression wave where its change would cascade across its entire length at the speed of light, kind of like a waterbed, but at a very long distance. So the compression wave of movement would travel at the same speed as radio waves do, which is also the speed of light. So actually, that's a fairly compelling argument for the universe being simulated. It would explain a lot of cruel ironies, like how, as a middle-aged man, it's easier to grow hair everywhere except for the top of your head. Ah, there we go. Oh, that peeled off quite easily, probably because it's all cooled down. Weird, it's kind of like a pattern. I don't know if you can see that in the light. That's interesting. It looks pretty good. I can see the chamfers and everything. Yeah, nice. Yeah, and once the bed is cool, it just pops right off. So that's good to know. So I'm helping a friend of mine with their bar. They want to make like an Atari bar. So I figured, why not use this printer to make some parts? So let's try removing the filament. Filament remove. All right, let's see how easy or hard this is to do. Okay, the extruder's up to temperature. I'm gonna just do it the same way, where I'm gonna basically open it up and then just pull it out. Let's see if it gets, oh yeah, that got past the Rubicon. There, I used a historical term, just fine. So we're gonna print a facsimile of an Atari 2600 switch, one of the front panel switches. So I'm gonna load in some black filament. I'm gonna put it through the filament sensor. I wonder if that actually can detect the rotation of the filament, or if it only detects if it's there or not. All right, I'm just gonna cram it right through. All right, we are printing these faux Atari switches. Let's see, what's the speed? I think it's 9,600 millimeters a minute. But yeah, compared to the Anycubic Mega Pro, this was a lot easier to load and unload the filament. Zero production value. I'm filming the screen. That's basically what it's going to be. Yeah, so my friend, he's got this at his bar. So this is under the tap area, and then there's actually wood grain and ridges out here. So it looks like the face of an Atari 2600. So we're basically 3D printing switches in a fake cartridge slot to make this look more like a console. They're done. I'm going to pull them off the table. See? And release them. Hey, that came off pretty easy. Didn't finish too long ago. The table's still warm. Right? And then, right? Is that what you're thinking?
That's good.
Okay, so I cut these chipboard patterns on my laser for the mounting holes, and then we've got our 3D printed switches, and then we'll use PLA glue to put, well, we'll paint this of course, but put the switches in place. So yeah, look at that. And then the cartridge slot will go here, and then there'll be 3 more switches on the right, but they're printing at the moment. So yeah, what do you think, Brad?
I think it looks great, Ben.
Yes, so I just hooked up this printer and I'm already using it to make projects for people because I don't waste time. I'm printing a much larger piece now for the faux Atari bar thing. And yeah, this is a really nice flat first layer that's being laid down here. It looks pretty good. One thing I noticed with this PEI surface, which I believe is what this is, yeah, you can flex it and make the part pop off, but if you wait for the surface to become completely cool, like if I let this print overnight and take it off in the morning, the part seems to release from this PEI material very, very easily. Because normally something this large and flat, unlike glass, would be fairly difficult to remove. So yeah, we'll see how easily this removes once these pieces are done printing in 4 hours. Okay, printing has finished. The total time is 4 hours and 50 minutes. Yeah, I was at a Christmas party. Don't worry, I Ubered back home. Look at that! That just came off like nothing! That's so cool! Like, that's pretty awesome how easily these parts come apart off this magnetic bed. I'm impressed. Check out that cool texture on the bottom. See, normally a part like this with so much flat surface area would be quite difficult to remove from a platform, but that just came off with no effort. Basically, so that goes like that. So that's the faux cartridge slot for the Atari. Pretty cool. Nice. Okay, I printed a part that I use for my left-handed Xbox One controllers. This part sometimes I have problems with glass because it's got little slits where tack switches fit through. But when you print it with glass, the bottom layer tends to get a little too compressed. And therefore, the slits might be sealed. Oh, look at that. You can see them. Well, actually. Oh, there you go. Yeah. Oh, yeah, the slits are nice and open. Cool. Well, I'll just keep printing some test pieces, and we'll see what else this printer is good at. I'm doing a fairly large print here. It's a control panel for a pinball prototype machine. Anyway, this one is just under 4 hours, so we'll see how it turns out, but hopefully this nice PEI bed will make removing it from the bed a snap. While we wait for that to print, here's a look at the Atari bar that we just worked on. As you can see, it's not quite done. It still needs a few details and graphics, but I think you get the idea. It's a very unique bar with lots of beers on tap. And here's a large print. Wow, it just comes right off like nothing. Let's see how easily the support removes. The top surface is pretty loose, but these edges need a little love. Of course, the support material is created by the slicer. Doesn't really have anything to do with the printer, but yeah. Just amazed how easily that bed releases pieces. Releases pieces. E.T. loves them. Yeah. Look at that. Pretty cool. The Anycubic Vyper. I really like this printer. I like the PEI bed, how it's magnetic, the nice touchscreen. I appreciate the advanced stepper motor drivers, and the fact that the thing runs off a 32-bit microprocessor now. Alright, well, if you're interested in one of these, I'm going to have links in the description below, and they're having a sale between now and, I believe, Christmas, so you can grab one for yourself. But I would definitely say this is a big step up from the previous Anycubic FDM printer I reviewed, which was the Mega Pro. This one's pretty cool.